everyone. Thanks for tuning in to SmartCon 2022, where leaders, builders, and contributors at the forefront of Web3 innovation come to showcase what's next for the industry. Our first speaker for today is Balaji Srinivasan, angel investor and former Coinbase CTO. He'll be exploring oracles and the on-chain census.
Today, I'm going to talk about something I'm calling the on-chain census, a way to prove the population of a digital community to achieve diplomatic recognition. And the digital community could be like a DAO or a startup society, or it could be something that we're calling a network state. And let me just jump in and kind of explain what we mean. So I'm going to talk about first the state of oracles, then the network state, then this concept on-chain census, and then wrap it all up. Okay, so first the state of oracles, right? So in 2022, oracles today are mainly used for price data. It's actually great that they are used. 5 years ago, they were more theoretical. They're, quite widely used, as folks here know. It's, price, while it might seem like an idiosyncratic place to begin for an outsider to the space, it's actually a good place to start, because you can kind of think of, price data. If you can transport it correctly, it's like Brinks trucks on the blockchain. You're using this information to guide multi-million-dollar trades, and if you can secure that, then you can potentially secure other kinds of information, which it's not as profitable to corrupt or what have you. Okay. And so with that said, though, there's a bunch of tools out there now, with Chainlink, there's the VRF, API where you can add randomness to smart contracts. There's the bidirectional stuff. So these are really good tools. But what can we use them for besides price related things themselves? And again, there's nothing wrong with price. As I said, it's a good place to start. But what I'm going to talk about today is something that's not about price, but about censuses. Meaning headcounts for DAOs, for startup societies, and for network states. So what is a network state? So, the fundamental concept is, if we know that we can start new companies like Google and new communities like Facebook and new currencies like Bitcoin and Ethereum, can we start new cities or even new countries? And so, I recently put out a book on this exact topic. It's called The Network State. Best-selling book on how to start new countries, Wall Street Journal bestseller. That's a real list, by the way. The NYT bestseller list is fake. The Wall Street Journal list is actually based on actual sales data. The NYT list is just an editorial product, as they had to admit. Anyway, so the Network State best-selling book on how to start new countries. It's also free online at thenetworkstate.com. So you can just go and take a look at it. And, it's a book length treatment, but if you want the quick version, here is really an image of at least one of the core concepts of the network state itself. And, it's essentially like a social network, except rather than being like Facebook or Twitter, which have many individual communities within, Twitter has 300 something million people, and it includes the supreme leader of Iran, and it includes folks from the Chinese Communist Party, and Americans of different stripes, and folks who speak different languages. Those aren't really people of one community. They use Twitter, but it's no more a community than the water using community. All humans use water, right? By contrast, if you imagine a social network that's a genuine community where all the people have something in common, they have the same moral values, and that community uses its cryptocurrency to crowdfund territory and network it together, that's kind of what a network state is. And here's like a visual of one that has, 1,729,314 people. And that's it in one image. Here it is in one GIF, where you start out in this example from one person in Tokyo, and that they expand essentially their community around the world. Starts with one person, and then 10 people, then they've got 100, and then 1,000, and so on and so forth. And with each leg up, they have more nodes in their network archipelago, and they have a larger annual income and more people and a larger footprint, right? And so this is actually quite cool, because you're in theory able to get something that is got the scale in terms of population and square footage and income of a nation state, but it's decentralized, just like, Bitcoin has the oomph and it has the size of a currency, like of a country, except it's a decentralized digital currency. It has no one geographic center. It's got a center in the digital space, but it's not, it's got miners and nodes and stuff all over the world. So all of that is good, except the problem is the network state, we're kind of assuming that this census at the top, this dashboard, is accurate, right? This census has the verified netizens, it has the annual income of the network state in subscriptions for society as a service, and it has this global real estate footprint. And the thing is that census, it has to be reliable. It's actually quite important. It's not just a network state that has a census. The United States actually has a census too. In fact, this is in the Constitution. There's lots of stuff that's in the US that's not in the Constitution. The census actually is. It's used for many things, including resource allocation. And there's also, the census, or a census, is used not just by the network state or the United States, but basically all states. They use their censuses for various things, among others, to be able to prove rank. It's not so much that countries are competing to be the biggest, but population numbers are used in many ways. And, so China's number 1, India's number 2, the United States number 3 in terms of population size. And actually, India is, I think, number 1 now, according to some metrics in terms of population size. So censuses are kind of used to prove rank, though that's not their primary purpose, but they're used for many things. And one interesting point about these censuses is, if you look at them, you realize that actually most countries are small countries. 38 countries in the UN have less than 1 million people. Reunion isn't a country, but Djibouti, Fiji, et cetera. These are real countries that have less than 1 million people. There are 67 have less than 10 million people. And so the majority, 38 plus 67 is actually greater than what's on this side. Only a relatively small number of countries, 14 countries, have 100 million plus people. Most people live in big countries, but most countries are small. And that's actually an interesting point, because if we combine it with another concept, which is that new coins use stats to prove rank, like coin market cap, Bitcoin, Ethereum, et cetera. The stats of market cap are used to prove rank among other coins, and to prove the rank among fiat currencies. So Bitcoin, if you go to fiatmarketcap.com, the much less known, cousin of coinmarketcap.com, Bitcoin is number 26 worldwide in, by market cap, according to this sort of idiosyncratic measure relative to other fiat currencies. Okay, so we put all those pieces together, that coins use stats to prove rank, that companies have censuses, or the countries have censuses, and that most countries are small countries. And we get the interesting kind of concept that a 1.7 million person network state would actually rank among the nation states of the world, somewhere in this example between Latvia and Bahrain, as a potential UN-listed country. Just like a new coin would rank on CoinMarketCap, if its market cap got high enough, a new network state would rank among the states of the world if its verified population got large enough. Now, of course, the key question here is, this has to be reliable, but if you could make this proven, and you could rank, you'd essentially, on the basis of just pure traction, or the basis of a verified population, you'd sort of eventually demand respect, or people would start giving you diplomatic recognition. And why is that? Because you basically just have a large enough population and income to be able to sign deals that were on par with the sovereign. You could have a sovereign wealth fund. You could do deals that were on par with the sovereign. Just you would be a different kind of sovereign. And of course, you get laughed at the first time, the second time, the fifth time, but Bitcoin was laughed at too, Ethereum was laughed at. And now today, Wyoming has given legal recognition to Ethereum. It's basically integrated with Ethereum. El Salvador has effectively diplomatically recognized Bitcoin. So these nation states have recognized these decentralized networks. And we might think of the concept of diplomatic recognition. These are both examples of diplomatic recognition by a centralized state of a decentralized network. We could actually look to formalize this and actually look to seek this as a goal. Given a large enough online community, can we get diplomatic recognition from a legacy country? I think that is possible, but only if that on-chain census is actually reliable. So that gets us to the third concept. which is the on-chain census. So again, as we said, as this network society grows, it proves its scale to others through the mechanism of this on-chain census. But immediately, what people will say is, just because something is on-chain doesn't make it true, right? You could have, yes, there's an API here, Chainlink or something else can put it on chain, make it accessible to smart contracts, but that API could be false because putting it on chain, it gives you guarantees around the metadata, like who wrote the data and when and what was written via hash, assuming that the this can't be unwound. There's some kind of proof of work style hash around it. So it gives you proofs around the metadata, but not around the data. Okay. So it's actually a non-obvious question. How do you create an auditable on-chain census, one where you have some degree of confidence in the data on this number, right? So just drilling into that population number for a second, if we think about how that's actually represented under the hood, basically it's like a drill down where, imagine a database which has 1,729,314 rows, and each is a .eth, and you have a binary indicator from an oracle saying this person is _human, right? That could be like an ENS field or something like that that's written to each of these. And you sum over this, and that's how you get that population number. The problem, of course, is that, as we just said, the API that's saying this oracle could be fallacious, and that one could actually be a 0. And if it is 0, then the sum over this column affects this. And so it could be honestly erroneous, or it could actually be malicious, and it could be making it all up. They could all be bots and just be called humans, or it could have something subtly different. It's saying, yes, they're all human, but they're not unique, and they're all the same human. So they're not a unique human, right? So there's various ways in which this could be screwed up. And so, how do we fix this? Well, there's the concept of the oracle network, right? Where we have multiple oracles. And with n oracles, we can now look at measures of inter-rater reliability. So in this case, we went from just one oracle to 2 all the way to n. And here we have, this first oracle is calling gym.eth human, but oracles 2 through n in this example are disagreeing. So unlikely that gym.eth is actually human, or at least you'd have to have some reason to reject all these other guys. And conversely, bob.eth over here is, there's a disagreement only by oracle 2, but not the other one. So maybe, put that in yellow, okay? And you can actually formalize all of this depending on how many raters you have and how much data you have. There's measures like Cohen's kappa and various other measures of inter-rater reliability. If you know any stats, you can, between any pair of columns, you can form a contingency table, like a 2x2, looking for 1, 1, 1, 0, 0, 1, 0, 0, calculate things like chi-square and various other measures of correspondence between any pairwise, set of binary indicator columns. And then you can form an n by n, basically a matrix, which has, the chi-squared stats for any I, j pair of oracles. And you can basically see the extent to which, just speaking informally, these things correlate or predict each other or what have you, okay? And, that might be very easy if you know stats or maybe gobbledygook. Point is, you can measure inter-rater reliability. There's ways of doing this. Once you have n oracles, you can look at how consistent they are, whether one of them is the odd man out, or whether they generally tend to correspond, and you start to reduce your dependence on a given oracle. Still, this is only relative truth. They could all be wrong in some systematic way. So you also have a mechanism for absolute truth, and that's your own data, where you spend the money to go and sample a subset of rows. In this case, we're showing, a sample of, basically 5 rows, but you'd have more than that, okay? You wouldn't do all 1 million, but you sample a subset of n rows from this giant, 1 million row data set. And you actually spend the money to go and independently verify, is John.eth human? We say yes. Is Jim.eth human? We say no. Jane.eth, Bob.eth are human? Yes. Foo.eth is actually human, even though the data set said no. We just count up all the mismatches, okay? These are like defects. And you're essentially randomly sampling a few rows. You're saying there's some mismatches. And this is actually very analogous to like taking the output of a factory. It's got 1 million something widgets. You select randomly a subset of 100 or 1,000, and you inspect them and see how many are defective. And then you extrapolate that out to the entire set, okay? And there's various ways of doing this, but you're basically estimating the so-called sample proportion, the percentage of defects, right? And if your sample is genuinely random and your verification is good, and let's say you find only 3% mismatches, okay, in your own audit, then you can use some basic stats to kind of extrapolate that out and get a bound on what's the probability that there's more than 100 or 1,000 or 10,000 fake humans in this data set. It's very similar to the kind of stuff that Elon is arguing with Twitter with over bots. Okay, and so this concept of auditing the oracles can be done by you, or you could have a third party do it, like one of the big four, like a Deloitte, an EY, KPMG, a PwC. Anybody can commission an independent audit, like by a big four auditor, and just spend the money on a random sample of rows to determine whether this oracle is trustworthy. And of course, you could apply this not just Oracle 1, but 2 through N, et cetera, right? Okay. So now you've actually got something where you're not just trusting, you can verify. And if you're basing a big decision like diplomatic recognition or anything even just less than that, like, listing or other kinds of things on this, if you're deciding to join that community, this allows you to do some independent due diligence. You're not just taking what's on chain on faith. You can go and collect the data yourself, or you can look at Deloitte and EY and KPMG and PwC's audits of these, or pay them to do an audit. And so we put all the pieces together to summarize. We introduced the concept of starting a new country. Okay, we made this, this visual which has this distributed population, but because it's distributed, people don't necessarily know whether the number reported in a dashboard is real. Putting it on chain alone helps in terms of provenance. It gives you at least a supply chain. Every individual point here is a .eth and can be individually diligenced. But if you're trying to rank among the countries of the world, we need to have better proof than just self-report. And so we essentially described a methodology for what we call an auditable on-chain census, where that population number can be broken up into a bunch of Boolean variables. You can audit them, and you can get effectively confidence intervals on the sampling distribution. You can figure out what is the likelihood that these are all fake, or some of them are fake, or only 10 or 100 or 1,000, 10,000, et cetera, are fake, right? And this can be generalized, beyond population, which is Boolean variables, to some of the other variables I mentioned, like income or real estate. It would just be something where rather than being ones and zeros, you have continuous variables. Rather than contingency tables and chi-squareds, you'd have scatter plots and correlations. And so if you're a stats person, you'll understand what I'm saying. If not, ask your statistician. But the point being that now we have a mechanism for getting an auditable on-chain census, which establishes the reality of network state, which potentially starts paving the way for diplomatic recognition of a completely new kind of entity. So thank you very much. If you want more, we've got a website at thenetworkstate.com. The book is free online. And I'm at Twitter at twitter.com/Balaji, where you can DM me. So thank you very much.
That was a great presentation by Balaji, and it's always cool to hear how Chainlink can power Web3 innovation. Now we're moving over to the land of DeFi and NFTs with our next speaker, Stani Kulechov, the founder of Aave and Lens Protocol.
Hey, everybody. I'm Josh Constein, venture partner at venture fund SignalFire. And today I'm here with Stani Kulechov, founder of social lending protocol Aave, and now the decentralized social networking protocol Lens. Stani, so nice to have you here. Thanks so much for joining us.
Thanks, Josh. Super happy to be here.
Awesome. So as I mentioned, I'm Josh. I was formerly the editor at large for TechCrunch, wrote 4,000 articles, was the #1 most cited tech journalist from 2016 to 2020. But now I'm at a venture fund called SignalFire. We invest in Web3, as well as infrastructure across software verticals. And we love helping our companies with recruiting, thanks to our recruiting engine Beacon. And there's a real reason why we have an NPS of 92 amongst founders. So if you want to find out more about that, let me know, hit me up. But I want to jump in with you, Stani, and talk a little bit about the promise of Lens. What is this, and why is it going to change the social networking landscape?
Yeah, I mean, Lens essentially is a protocol that is running on the blockchain, and what it gives to the user is their self-identity on chain. And what it means is that, for example, today when you are using social media, you're going from one platform and you're creating your profile there and your audience and your followings. You can't actually port those followings into another application. So essentially you are creating your presence across different platforms. And what Lens Protocol is achieving is that it brings the ownership of your social presence actually to you and changes the dynamics that each application can actually build an experience on top of your own social graph and giving you experience how you communicate between you and your audience. And it's on chain, meaning that we also use NFTs quite a lot in the empowerment for the users. So the profile is NFT that you can actually move along from safe custody to another addresses. And then, of course, the following relationships are NFTs as well. And all the content in Lens Protocol also are collectibles as NFTs. So the users can actually monetize directly their content that they're sharing with their audience.
That's awesome. So what does the day-to-day experience of being on Lens feel like? And maybe contrast that to like a traditional social network.
I think the biggest difference is that you create your profile once. So once you have created your profile, you can actually use different applications that are built on top of the Lens protocol. So for example, traditionally you go and sign into one application, you create your profile in traditional social media, and you create your followings there and your network. In Lens protocol, actually, you do it simply once. So you have the same social graph that all these applications are leveraging at the same time and even growth hacking. And I would say that currently we see a lot of different applications being built, mainly experimentations. Developers are rebuilding applications that they see in the traditional social media and combining features that they like the most. But what it allows actually to do is it brings a lot of freedom for the user, because essentially you can get a new experience without actually losing your social graph or your presence if there is some interesting way of interacting with content in this same social graph.
I feel like the thing that I'm most excited about here is the concept of how social graph portability and the ability to really take your network and audience with you really means that the social networks or the application layers here have to treat you well, that like they can't abuse you and exploit you for your labor and content or overwhelm you with ads or violate your privacy, because they know that you can just take your profile somewhere else. You don't have to start over. And I think that lock-in has been why social networks like Facebook and Instagram and others have been able to kind of exploit their audience, because they know they're really stuck there. And so maybe tell me a little bit about what does that unlock for users and how they operate differently on this social network because they have that portability, or how does that kind of change the power dynamic between the platform and the developers and the users?
Yeah, if we compare, for example, into traditional social media, we're actually giving a lot of data for the platforms, and we're training their algorithms, we're providing content, and we're essentially supplying, we're the suppliers of the feedback loop, but at the same time, we, the users, are also the consumers in that specific feedback loop. So we are essentially giving data. Based on the data, we're able to actually, the platforms are able to know exactly what we want and sell different kinds of services. So we, the users, are the product within the platform itself. And for me, it's fascinating because with Lens Protocol, the dynamics are changing in a way that now that you actually have the freedom and the ownership of your social presence and your social graph, essentially those applications and algorithms need to work for you. And this will mean that not only the applications have to work on the experience itself and aligning towards what you actually want from the application and the algorithms itself, and finding the content that is valuable for you and being fair algorithm at the same time, and even transparent. But also the applications and the products has to be aligned with the users' values as well. Because if that particular application or experience isn't in line with the users' values that they stand for, you can always go to another experience. So it really democratizes how we use social media today. But at the same time, it actually doesn't discriminate the entrepreneurs or application builders that are focusing on building applications, because essentially it takes a lot of load out of the back end, since there's a social graph and everyone can use it as a protocol, and simply focus more towards building better algorithms that are more fair and transparent, building experiences that actually compete of the users. I would say not maybe attention, but in general how they want to interact with the content itself. And last kind of like a point is that you can actually, as a developer of social media, focus also on building more brand awareness and the visualizations that we don't see today in traditional social media. Everything we see is pretty much already kind of like very used for us.
I know for a lot of social networks that one of the big unlock moments is when you start to have these real IRL connections that come out of a social network. Like when people start to get married on your social network, you kind of know you've made it. Like, what have you seen, or what are the kind of milestones you're excited about? Maybe for like a decentralized social network, it's like, oh, they didn't form a marriage, they like formed their own country. Like, what does this look like? You know, what are the milestones that you're excited about seeing in terms of the influence of Lens on your users' real lives?
Some of the quite amazing things that we added on the protocol level is the ability to collect content. So essentially, there is this idea of user-generated content as an asset class. So today, for example, we're collecting NFTs in the form of, for example, digital art or some sort of access control. We call it token-gated NFTs. And at the same time, we're seeing more expansion towards actually being able to collect also memories that might be other content, and specifically user-generated content, which it can be music, it can be also digital art, but also text-based content itself. And for us, like a lot of hero moments at the moment within the protocol is actually seeing a lot of interesting applications being built in different hackathons that we've been participating over the past months. But also seeing that some of this content are getting collected and users are setting actually collection fees as well. So we actually see direct monetization going towards the users instead of the actual platform itself. And for us, it's somehow also very groundbreaking, because it means that every user on Lens Protocol actually can monetize to whatever they express within their content publishing. And I think that's a very big, powerful moment for many of those. There isn't that many, the network is still small compared, because it's a closed beta, but we have already seen for the past couple of months 200,000 worth of value being generated from the content that the users are sharing across the Lens protocol. And extremely interesting observation is that it's usually the peers that are collecting and the followers that are excited and friends itself. So it really puts a lot of value towards the idea that there's a creator in all of us. And I think for us, the protocol itself is quite fascinating in terms of the technicality itself, because it's very modularized. You can create different kinds of collection modules, for example, that you can use Chainlink oracles to distribute some sort of pricing data or data from off-chain, which actually can determine whether you could actually collect some particular content of a follower or even follow someone. And I think this is very valuable, because if you take a look into the like a bigger picture, we have this incredible Web3 footprint data that we're using to allow these different communities to participate or following. But there's a lot of actually data generated by the users outside of the Web3 ecosystem, and they might be newcomers into the space and might not have this wide Web3 footprint, but you need to create the equality between whoever was early in the Web3 and whoever were interacting in the off-chain ecosystem. And I think that's where oracles and Chainlink bringing the data into the Web3 and into Lens protocol could be very fascinating use case.
I really like that idea that the networks have to adapt to the users rather than the users having to adapt to the networks, which is really traditional, as well as the idea that you actually help people earn money right off the start. Very few social networks did that for, the first like 10 years of their life. So the fact that, Lens isn't even out of closed beta and you guys are already making sure that users get paid really matters. And, one thing I'm interested in is that, the first instantiation of social networks, or like the decentralization, really how that changes the core norms of a social network. Like I think of on a traditional social network, people basically make content, try to outwit the like centralized algorithm, gain attention and followers, and then maybe send traffic elsewhere to monetize it through like an e-commerce shop or subscription somewhere else. How do you see that kind of flow of user behavior changing or being different on Lens, where it's not that one centralized network? There's a lot more freedom to monetize. There are native monetization opportunities. How does that change the way we behave on Lens instead of something like Instagram?
Yeah, the monetization brings direct monetization brings a lot of value for the users. Maybe also like kind of like on a conceptual level that it brings the idea that everyone can actually monetize whatever they're creating, and that can become very surprisingly. We all have value and we all have expression that actually can be collected by someone else, and it brings a lot of joy, happiness, or interesting thoughts or inspirations for many of us, and that has value. And I think like regarding like human behavior, I think, and social behavior, I really like the idea of actually making technology to reflect how we humans behave, and kind of like not modifying it to direction where we're supposed to act because of the technology itself. So I think tech can be used to actually improve human behavior, to create more net impact. But at the same time, like whatever we're building, whether it's Web2 social, on-chain social, we have to reflect how we interact socially in real life, and how our brains have been designed for centuries and ages. And I think for us, kind of like the ability to reflect, we built the protocol in a way that you can reflect the human behavior pretty much quite flexible way. So it caters a lot of the use cases in terms of like being able to connect with peers, share content, and have meaningful discussions. But in terms of like the monetization itself, I definitely agree that we've been in Web2 social focusing quite a lot on the advertising, sending traffic. But when you actually remove the barrier to enter and give the freedom, flexibility for the users to choose what is actually cool and what is useful for them without sacrificing their whole follower base and their identity or the brand they created, we actually are able to bring more creativity. So we, the application developers as well, and communities have to figure out what could be those tools and how the monetization could work and how we bring value to the users, because it's not anymore feasible that we can actually build business models based on only referring traffic in the same way. We have to actually build value and experiences and brands and retention, like why people are coming to a particular community and why they are enjoying the experience, and also keeping the innovation curve constantly going on. So it really creates interesting dynamics, but also we will see users bringing a lot of loyalty to those builders and applications and experiences that are actually bringing them a lot of value, and that creates a lot of stickiness as well.
Yeah, I mean, like when you walk into a party in the real world, you don't go in and say, "Hey, everybody," and you just like try to like, take over the center of the room and then be like, "Hey, everybody follow me to this other place. Like come back to my house where I can sell you things." It's awkward and it would be really intrusive. And instead it feels like, hey, because you can actually earn value through the NFTs and the followings and the collections of content right on Lens, you don't have to spend half your time doing a song and dance to get people to go somewhere else, which I think is like one of the most annoying parts of being on any social network is like, yeah, they're not actually providing inherent value. They're just trying to like pull me somewhere else. And if you actually build those value accrual mechanisms into the network itself, they don't have to do that. They can just make the network better for everyone. They can actually create native content that people want to consume there. And I'm excited about that idea. And, I also think one of the big questions for you though is, does the first instantiation of a mainstream sort of scaled decentralized social network, does it look more like a decentralized profile and then all of these little decentralized social networks that are built around it? Or does it look more like a traditional social network with some decentralization aspects and then a bunch of like apps that plug in and maybe they modify the experience, but they're not like a completely different experience? Like, is it more like Twitter with a bunch of plugins, or is it more like this floating decentralized profile with whole networks built around it?
I am a true believer in the networks model, and mainly because what I have realized during the process of building Lens Protocol is that the reason we have the centralized big platforms is mainly because we solve a lot of kind of like challenges that we had going from Web 1 and Web 2, and essentially bringing the ability to share content, interact content, and doing it in a very centralized way brings a lot of efficiency. But I think kind of like now that the platforms have grown quite big, it's very hard to actually go and compete against what they have in terms of the network effect. And I think that is fine. I think there's going to be attempts to rebuild Twitter rebuilds, and you will see a lot of Twitter clones. And I personally think they will not get that much of a traction. But what we'll be actually seeing is that now that you don't actually have to focus on building that massive network effect that we saw, for example, happening in the Clubhouse example, you can actually focus on simply creating something very valuable to a particular user group and create an interest graph out of the social graph. So essentially, those users, when you have this decentralized social media profile, are fascinated about that particular topic or interest graph, they can actually subscribe into it and that experience. So we'll see probably a lot of smaller applications, and by small it might be millions of people. It doesn't need to be billion people on the same platform. And this goes back into the Josh, your party example. For example, I might want to go party with my friends and listen to specific music, but I necessarily don't do that the same exact thing with my parents, for example. So that's a different kind of social graph, interest graph as well. And I think we will just see more new things coming up. And I think within those new things, that is where we might see a lot of traction. We might even see some of these applications becoming as massive as having billions of profiles over the long term as the blockchain itself scales. But we have a lot of opportunities in those smaller applications. So that's why I believe more about building something new and seeing kind of like those new parties coming in and how people form compared to taking completely down what already exists.
Yeah, I really like that idea. I think the concept that you get to decide what part of the network you want to use, and there's not this context collapse that you experience on traditional social networks where, your bosses and your coworkers, your friends and your family are all in the same network interacting directly, and you have this chilling effect where you like, what do I say that's appropriate for all of them or interesting to all of them at the same time, and instead thinking, okay, I can operate differently in these different these different environments, the way that we really do exhibit prismatic identity in the real world. So that brings me to one of my final question, which is really what are you excited about that's being built in the ecosystem right now, and what do you want to see built? Like, what as a request for startups or request for applications from developers, like what do you hope people start to build on Lens?
Yeah, well, I think something that is very fascinating is we've seen a lot of very kind of like still a bit normal application being built on top of the Lens protocol, but there's actually interest usage. For example, we've seen, for example, posts in the Lens protocol where, for example, you see users actually saying that, I need an answer to this particular question. If you have the right answer, post it here and set a collect fee of 1, 2, or 5 Matic, and I will basically collect the answer that is most valuable to me. And we start to see kind of like a very creative way of using the applications that has been built. But there's interesting things happening at the moment. For example, we saw one application where it's called the Orb, where you actually come and learn about Web3, and based on your learnings, you get more badges, and on top of that, you can share your portfolio experiences and all this data. Actually, different kinds of Web3 job openings are shown to you as the user. So it's actually interesting value proposition because there's so many things to learn in Web3 as more and more talent is coming into the space. So we see kind of like more of these micro applications that are focusing on talent onboarding and creating that social experience there. And the cool thing is that you can be actually part of that application, and that's very useful for you. But at the same time, you might be using a photo sharing application with the same exact decentralized social media profile, but the curation will be for you different. So you will not see other people's achievements and, for example, what kind of courses they made and congratulate them for that. You might only see the photo sharing aspect. So that's the beauty of decentralized social graph, that you have the protocol underneath, but then on the application level, you can actually create quite a lot and build a lot of functionality and experience.
Yeah, that's awesome. So I think everyone should be on the lookout for their opportunity to create their own Lens profile and get involved, because I feel like this is a whole other opportunity to feel early. And if you're building something in the decentralized social networking ecosystem or software infrastructure, hit me up. I'd love to hear about it at our fund SignalFire. We're $1 billion under management, and we love investing in infrastructure companies and helping them with recruiting. So please let me know if you're building something in this space. But Stani, any final word to builders and people excited about the future of decentralized social networking out there?
I would just urge anyone who is actually building and interested in this space to build something very cool and reach me out on if they have some interesting ideas, and also whoever isn't aware of the Lens protocol to read a bit more and reach out as well if they want to have an access as well. And super excited to be here today as well.
Yeah, thanks. And I'm excited for everyone to go out there and build their own version of what they want social networking to be. So for me, Josh Constein from SignalFire and Stani from Lens, thanks so much for joining us. Talk to you next time.
A huge thank you to Stani for that awesome presentation and some great thoughts on the opportunity available in Web3. Our next presentation goes a bit deeper into the Web3 stack, right down to the base layer, with Christian Reitwiessner, team lead and researcher at Ethereum Foundation.
Hello, everyone. My name is Reitwiessner. Thank you for giving me the opportunity to give this talk here. I'm sorry that I can't be with you in person, but yeah, I hope you'll like my talk anyway. I would like to talk to you about the latest features of Solidity as a language and of the compiler, and we will also talk about current challenges and upcoming features we want to add next. Yeah, we'll start with the IR pipeline that we recently released or declared stable. Then about errors and encoding, the immutable keyword, then something I'm really excited about, the user-defined value types. And this leads up to generics that we want to add to the language, a standard library that will make heavy use of the generics. And in the end, I want to talk to you a little bit about how we plan to optimize memory. And one candidate for that is reference checking. So let's start with the IR pipeline. We declared this, so this has been in the works for quite a while. We started to use it for the ABI encoder v2 way back. And it is feature complete for, I think, at least a year now, and we declared it stable in March. What I'm actually talking about is a parallel code generator pipeline that uses an intermediate language and does not go to EVM directly as the first implementation of the code generator does. And the benefit is that this gives us way more flexibility. It also allows you to audit the code the compiler generates, so you can actually take a look at the assembly code the compiler compiles a smart contract to before and after optimization, which is really cool. And it also allows us to have way more opportunities for optimization. For example, we can do cross-function optimization, which is not really possible with the old way we did it. And currently we have comparative or in many cases better gas costs for the smart contracts. One tiny drawback currently is still that the optimizer is a bit slow on the ULIR, but we're working on that, and yeah. Oh yeah, and one final note, if you want to take a look at the optimized intermediate representation, then use the, as you see in the third line here, use the switch IR optimize to request the output, but you also need to activate the optimizer using ---- optimize, otherwise the optimized output looks the same as the non-optimized output. Then just quickly about errors and encoding. This is these features are a bit old already, or I mean, not so recent at least, and you probably know about it. So you can define errors that take structured data as arguments, and you can use them in revert statements. So you can provide structured data to the caller, who then can analyze a bit better why some operation failed. We have bytes.concat that can be used to concatenate byte arrays and strings. We also have byte array slices now. And there's a feature or a function called abi.encode call, which takes arguments to be encoded for a function call, an external function call. And the benefit over what we had before is that it takes the function as an argument, so the compiler can perform type checking on the arguments and so that they match the parameter types of the function. And it reports an error if they don't match. Okay, now on to the immutable keyword. This is a nice way to declare a state variable to be constant, but only after the construction. So you can have an immutable variable that depends on constructor arguments, or for example, on msg.sender, like the owner variable here. So this is a token that has an owner, but we know that the owner will not change over the lifetime of the token. So we assign it msg.sender in the constructor, and the Ethereum virtual machine actually enforces that the variable does not change. And the way this is implemented is very efficiently, because we do not take up a storage slot for these variables, but instead the value that is determined in the constructor is actually copied to the places in the code where this variable is used. This makes it extremely cheap and yeah, safe at the same time. Now, yeah, onto one of my favorite topics, user-defined value types. Let's start with a bit of a motivation. So we have a function here called approve that takes a token ID, an amount, and a start date. And currently, the best types you can find, or before we had user-defined value types, the best type you can find for these parameters are unsigned integers. So we take 3 unsigned integers here. And then later, when we call the function, we call it with amount, start date, and token ID, which is, of course, yeah, the variables are swapped around here, and this will have very bad consequences. But the compiler, it doesn't complain because in the compiler's view, everything is right. So the types all match, so there's nothing it can do. And it would be much better if we had different types for the different kinds of data here. So for example, in the second part here, we have a token ID type for the token ID, a DAI amount type for the amount, which also gives you a way to say what kind of amount it is. So is it a DAI amount or an Ether amount or whatever? And a date type for the start date. And now if you have a parameter ordering confusion here, then the compiler will give you a type error. So this is a really nice feature, but the question is it also cheap? And that is a clear yes. And this is because, so you were able to do something like this already in the past by using structs, but structs are always allocated in memory, so they are quite expensive and also have these reference semantics, which are a bit complicated to use maybe. So we introduced a way to define a new type that is stored on the stack. So these new types are always value types, and you have to provide an underlying value type it is kind of built out from. So you write a token ID is uint, and this creates a new type called token ID, which is stored on the stack. And it's, yeah, all its internal semantics, so the memory layout, the storage layout, and so on, is taken from uint, so from the underlying type. But that's the only relation it has to the underlying type. It's it's a completely fresh and new type. It doesn't have any functions. It doesn't have any conversion rules. It doesn't have any operators, nothing. These are all things you can add your own later on. So the only thing that the compiler provides is a specific conversion function between the underlying type and the new user-defined value type. And this is called, these are the functions wrap and unwrap. And they are defined on the type word itself. So here we are building our own custom fixed point type, and it's a 128-bit type, and the underlying type is uint 128, and we define a function called uint2fixed. And here, especially for fixed point types, there are 2 ways to convert from an unsigned integer to a fixed point type. The first conversion is just the kind of raw conversion of the underlying type to the fixed point type itself, where nothing changes. But this is usually not what you want for the user. What you want for the user is, if you have a function and you input 1, then the result should be the fixed point type 1. So you have to scale this 1 by the fixed point type multiplier. And that's why you can use, as I said, this fixed.wrap for the underlying raw conversion. But this conversion is something that you usually should not expose to the users. The user should only use this uint2fixed and not care about what the underlying encoding is. One final comment to this for this type token ID is uint. This is not a type alias, so you can have as many new user-defined value types based on uint as you want. So this is just the relation to define the underlying encoding. So now, now we have defined the type itself, And we can add functions to the type as follows with the using statement. The using statement that already exists to add library functions to types, or library functions or file level functions, and you can use that to just add them to the type as you're used to. And we also have a new cool feature for the using statement, which is this global keyword at the end. This adds these functions to the type globally in the whole project, and you do not need to repeat the using statement when you use global. The main restriction for global is that you can only use it for types you defined yourself, and you can only use it in the same file where you defined the type. So the idea is that you have a module that defines a type, and you also define the functions the type takes, and then use this global keyword to just permanently fix these functions to the type. And then wherever you can use the type, the functions are also available. And when you have an external module, you're not allowed to add new functions on top, at least not globally. Yeah, I won't go through this code in detail. It's just, there's an example where you have in a different file, you have the function square, and it can just use x mul x without actually importing this mul function from anywhere. And this is nice, but of course, x mul x looks horrible. I mean, many people in this space are probably used to this by now, but I still think it looks horrible, and it's very, very hard to audit, especially when you have such nested operators. And that's why we also want to add user-defined operators as a feature. These are added to existing types in a similar way as functions are, but you just have this as operator. So using add as plus for fixed global, this or using mul as star for fixed global makes the multiplication operator globally available for the fixed point type we have defined, and it calls the mul function. So we have a function called square here, and we just write value times value. So of course there is always the criticism that this of course makes it more readable, but also more complicated because you don't always really know which function is called for this multiplication operator. But we are working on the language server, and as soon as we release these user-defined operators, we will also release the language server, which allows you to do just control-click on the multiplication symbol, and then you jump to the function that is called. Another feature is what we're working on is a literal suffix notation that allows you to easily use constants with your user-defined types. So you can write things like value times 1.15 underscore f, and this will then call this underscore f function on this constant 1.15. There's a little complication due to the encoding of fractional numbers that we will provide extensive documentation on when we release the feature. One open question here still is how we declare these suffix functions to actually be suffix functions. If you have any input there or have an opinion, then we welcome you to our discussion forums. Then onto the standard library. So the standard library we are working on is not meant as a standard library that has like standard token implementations or these smart contract templates you usually use, but instead we want to take functionality that is currently baked into the compiler and extract it into a library that is actually written in Solidity and can be read and understood by people who know Solidity. So for example, there's currently this magical global function called addMod, which is modular addition. and it's available everywhere, which is also weird. So with the standard library feature, we will also have the requirement that you need to import all these globally available functions explicitly from the standard library. And then this add mod function will be implemented in the file std/math.sol like this. So it will drop down to inline assembly, of course, because at some point you have to reference the built-in opcodes. And the cool thing here is currently when you wonder what happens when you use add mod with 0 as modulus, does it revert? Does it return 0? And currently you have two options. You either look in the documentation or you look in the compiler source code. But this is both a bit, I mean, you're writing Solidity code all the time, so it's much better if you see the Solidity code and see, oh yeah, it just has this require modulus is not 0 check at the beginning, and then you also see which kind of revert it does, whether it provides data together with the revert or not. So I think this is a really cool feature. And of course, we won't get very far with the standard library without a mechanism to write generic code. And this is another thing we're working on. It will, of course, not only be available for the standard library, but also for user-defined code. And we're currently leaning towards a mechanism that is rather strict than loose. So we want to have a mechanism similar to how Rust handles generics, in the way that, for example, here you have a max function, and it takes two generic parameters, but it requires that the type of these parameters implement a comparison function. And this allows us to do full type checking at the point where we type check the templated function itself, instead of only at the point where the function is used. So C++ has this weird mechanism where it only type checks the template at the point where it is used and not at the point where it's defined. This makes it a bit more complicated because we have to introduce all these notions, comparable, maybe copyable, and whatever, but I think this additional work is worth it. Here, the main open questions is how to handle the data locations, because you can't have mixed data locations, so you can't have a storage array that has memory pointers. So the storage location is rather tied to the variable instead of the type. And there's also the question whether or not you want to have implementations that are generic over the storage locations. So, for example, this max function here, you probably want to be generic over the storage locations because there's no other way you would implement it. But appending to a resizable array, there it makes a big difference whether it's a storage array or a memory array. Okay, then the last topic. When Solidity was initially designed, we were mostly thinking that transactions would be kind of short-lived, short-running, with only a little gas, and they won't do much. But this has changed a little in the past, and smart contracts are getting more and more complex, and they're using more and more memory. So in the beginning, we thought, we can just allocate memory and never deallocate because it will be cleared in the next EVM call frame anyway. And now it looks like it is worthwhile to think about a better memory allocation mechanism. So I have an example here. We have a loop, and this loop fills a storage array with structs. In the current implementation, this struct constructor will create a struct in memory and then copy it over to storage. And the bad thing here is that it will create a new struct in every loop iteration. And of course, it could just reuse the memory location of the previous iteration. And in this special example, all the structs are equal, so it's even the same content in memory all the time. So this is one of the first things we're working on: determine lifetimes of memory objects and deallocating them, or at least allocating them in a special buffer that can be reused or something like that. So, and yeah, a big open question here is, or a research topic, what is the balance between implementing a more complicated allocator that is kind of also looking for places to allocate memory and deallocate memory, and the additional overhead it has compared to the memory it saves. Okay, we always welcome anyone who would like to participate in language design. If you have ideas or comments or problems, then you're welcome to join in the discussion. We also really welcome people who help us prioritize issues. Yeah, how you can contribute can be found in our documentation. We also have weekly meetings on Monday and Wednesday, which are always open to the public. So you have any comment, just hop onto our meeting and talk to us. Other things we do is one-to-one feedback sessions, where we reserve some time to talk with one person about what they think about Solidity. We do the yearly user survey in December, so please participate in that. And yeah, we have a forum and a chat to talk, and we'll be happy if you follow our Twitter account. So thank you so much for your attention.
A really interesting presentation by Christian Reitwiessner. Next up is Homan Farahmand, VP, Research Analyst, and Advisor at Gartner, who will dive deep into Web3 digital identity.
Hello, everyone. Welcome to this presentation. We are going to talk about how decentralized identity and verifiable claims disrupt identity and access management. So we believe that decentralized identity will disrupt relationship architecture. So relationship in this context means how different entities connect to each other. So we are going to move from an organization-centric model that organizations solely register different users and issue a digital identity for them, to a model that users have the options to create their own identity and register organizations that they want to have relationship with. So this has a far-reaching impact, which may not be obvious when we talk about it. So we are going to go into some details and see how this change, this technology will impact the business model and also digital identity infrastructure. So let's begin by talking about how decentralized identity disrupt business models. And it really comes down to the digital identity acceptance model that will be broadened in our opinion. So if we look at digital identity, it's inseparable from digital ownership and accountability. So the question is that how we can establish a model that's scalable and hopefully universal, that guarantee to users when they own something, they own it anywhere. And same thing with accountability, to make sure what happens and what people do with their digital activities, they can be accountable for that. So in Web 2, unfortunately, the digital identity is built on the back of a model which is quite fragmented and organization-centric, because different organizations can only trust their own issued digital identity. And there are platforms that play as identity providers that create a lot of challenges from security perspective, from privacy perspective, from interoperability perspective, and more we see from regulatory issues. I mean, there are many super platforms that, as you may have heard, they try to own the digital identity space and offer different business services around it, which has created some concern. So all in all, this model has been proven that is not as scalable as it should be. And it creates, a lot of challenges in terms of integration and helping, users to have a smooth experience in digital ecosystems. So this whole idea that the Web 2 digital identity model can be carried over to Web 3 is not quite accurate. And with Web 3, put it simply, we mean an environment that business services are offered in form of a business utility, that they are dataless and they are more neutral in terms of digital identity. So we are currently in a period that we see a lot of effort to make digital identities in both Web 2 and Web 3 coexist. But once we can remove some of the current constraints and deal with some technological issues that digital identity for Web 3 goes mainstream, then there will be a big pivot from Web 2 digital identity model. So the question is that what the Web 3 digital identity model will look like. And I hinted already that the model needs to be more neutral, something that we call digital identity neutrality. So digital identity neutrality enables a more inclusive, fair, and secure issuance of digital identity, custody, and use of digital identity, and its relevant data. So, and this is very important because we are at the point in time that organizations require or need to rethink how they envision digital identity in their business. If you notice, over the last couple of years, a lot of Web3 associated businesses, startups, blockchain platforms are paying more attention to digital identity because now there is a more common understanding that for Web3 to succeed, we need to have a good understanding how digital identity works in that type of environment. So the idea is that organizations need to think thoroughly about their vision and make sure their model enables the use of any proven and verifiable digital identity without any biased stored identities that are issued by themselves. So, and that can be just opening a channel to accept decentralized identity to begin with in parallel with anything they already have. And this digital identity should enable and support a programmable economy that allow eventually a more universal digital ownership and accountability, either in physical world and virtual world, as we see more with metaverse and what's happening there. So the benefit of digital identity neutrality can be quite comprehensive. And this may not be clear to some organizations that may feel threatened by losing the control over digital identity. They had that model for many years. But in fact, once organizations have these neutral channels, they can open channels to any digital ecosystems that are compliant with Web3 architecture much easier. So that means more opportunities and faster time to market to respond to market opportunities. The other factor or benefit is increase in economic activities, because we will see that digital identity scope can be broadened, from simple authentication and authorization and more into areas like ownerships, data management, data marketplaces that can offer a lot more than it used to be. And the third one is enhanced security and privacy by putting users in control of their data, or at least give them this option that if they want to control their data themselves or select agents that custody their data for them. So I think the key takeaway is that digital identity neutrality will pave the way for decentralized identity adoption, which plays a key role in growth in Web3 adoption and going mainstream. So having said that, now let's focus more on digital identity infrastructure and how that's being disrupted. And this is really comes down to pushing a complexity that is associated with digital identity and access control more into lower level protocols. So with decentralized identity, we know that we can enable Web3 type verifiable claims and hopefully eventually self-contained private data pod that can persist identity data and isolate that from business services that are offered in Web3, or something that sometimes I refer to it as dataless business services. So with that in mind, we actually can enable a more common model for digital identity or digital ownership and accountability in different ecosystems. So if we look at what's happening at this point in time, we see that there is a lot of effort to build the foundational infrastructure for decentralized identity, which is pretty much focused on doing some basic identity proofing and authentication. But once, let's say, give it another 2 years from now, once that foundational infrastructure is in place and we go mainstream, the functions around this established digital identity can be broadened quickly. So we already see some interest to broaden this functionality to authorization. So people are talking about or actually experimenting with issuing entitlement in form of verifiable claims, or even taking that to the next level and issue NFT to establish eligibility and entitlement. So, but that can be extended into a more advanced ownership models around the established identity, and also more advanced data management functions. For example, right now we have the specification for organizations to issue verifiable claims, but that can be extended to people themselves to issue verifiable credential to other entities. For example, when you want to kind of assign power of attorney to another person, you can issue a verifiable credential that's signed by an attorney or a notary, to give that authority to someone else. So there is a lot that can happen in this area. Another consequence of this model is that we can establish pluggable digital identities that can be used in different ecosystems. So, and that allows people or different entities to attach their digital identities to those business or data-less business services, or let's call them public services, and participate in an interaction or a transaction. And this is all done by some verification protocols to make sure all the controls in place. We prevent, the complexity of configuring different systems, that can be bothersome. And I'm sure, you all have seen examples of it over the years. So that having that portable, attachable digital identity is a big step forward. And we see the evidence that these verification protocols can implement zero knowledge technologies, that even prevent, the data to proliferate as much as it does today. So a good example is, for example, the verifiable credential exchange protocol that's being used now. And also we see the signs for some emerging technologies like Chainlink Beiko that can play a role in this type of transactions. I think the third area that it's interesting to observe, the ability to open context-independent channel. So you not only use, for example, that digital identity for authentication, but you can participate in different type of business processes, whether it's related to education, financial services, interaction with government services, or different type of transactions that happens through the life. So all can be built around the same digital identity. So, and I think that's a big win, rather than we implement and deploy systems that are digital identity systems that are more context specific. So now let's go a little bit into more detail that talk about how these things happen. So basically, if you look at the different dimensions of disruptions here, it really comes down to three key areas. One is trust model, that we are pushing it to having a more shared trust infrastructure. Or in fact, we can envision to establish a public trust infrastructure that can be used by a lot of different ecosystems. The second area of infrastructure disruption is around access control, which, as I said, we are trying to push some of these controls into the protocol layer. And the third one is around data ownership, which basically we want to enable decentralized data and decentralized data exchange capabilities and put the user in control of their data. So let's unpack each of these a little bit. I think in terms of public trust infrastructure, you can imagine how much added efficiency we can have with that. So the idea is that we build these identity trust fabrics, which are really implemented through some kind of a decentralized public key infrastructure. And that allows users to register themselves once and prove themselves once, and use that in many different contexts by all participants in an ecosystem to verify their identity or data associated with their identity. So that identity trust fabric will be a medium to share metadata or any type of documents that can make their public key, the user's public key, discoverable. So where we are in that process, we have the ability to establish closed identity trust fabrics at this point in time. There are examples of public identity trust fabrics like sovereign network there. The challenge is to make these models work in real life with all different type of practicalities, different legal and financial requirements. So, so our hope is that over the next few years, we see a more interoperable identity trust fabrics that can be deployed in different domains and they can coexist, or even having the options of a true public trust infrastructure that everyone can use. So the other area we talked about was protocol layer controls. And that's an area that we see potential for enhancing the privacy. So the idea is that a lot of access controls and policies that are enforced at the platform level at this point in time, we want to push those controls and policy enforcements into identity protocols. Again, as I said, verifiable claim exchange could be a good example. And we also monitoring emerging protocols in this space. There are some of them that's coming. One more area that I'm looking at as well is Chainlink Deco to see now how that can support some of different use cases moving forward. So in terms of where we are in the industry, there is a lot of work that's being done to integrate more native Web3 approaches to what already exists in Web2. There is a lot of work that's happening in terms of implementing interoperability between all different models there. And that's an area that requires more work. We have too many of everything at this point in time, so we hope that there will be more standardization and eventually pivoting to a Web3 model with privacy enhanced technologies and the type of protocols that in a way we don't even feel they exist. So they are so low level and they're exposed to developers in a way that they write applications and protocol take care of many of the issues that we had to implement at the application level. So the next area is the decentralized data. Obviously that's an area that can help with reducing security risk by preventing data proliferation. The idea is that issuers issue data for different entities once. They sign it, they pass it to them, and they can hold it that data themselves or through their agents. And whenever a verifier wants to actually use that data as part of a transaction, they can provide that data with their own consent, and that can help with the verifier to complete the transaction or any interaction that's intended. So this is quite an important step forward. It basically streamlines a lot of processes rather than we keep proliferating data by sending the data to all different entities and not knowing what will happen with that data, whether it's used for other purposes, so on and so forth. So there's a lot of news stories about some horror stories over the years, so we don't need to go through that again. So one key component that's instrumental in making this happen is identity wallets and hopefully data pods. So we are at the point in time that we'll see multi-purpose but proprietary identity wallets that can facilitate, some of these activities. We hope to see more interoperability between identity wallets, that we don't make the user install multiple wallets to participate in different ecosystems. And in fact, this identity wallet become extremely important for Web3 because it can play the same role that browser did for Web2 for Web3, because as you remember, it's the identity wallet that allows the user to attach their digital identity to different Web3 business services and participate in different transactions. So I think our hope is to eventually, with better standardization and better interoperability, we can enable that universal identity wallet model that enable that universal digital ownership and accountability that we were talking about earlier. So now, with all the benefits I mentioned, it doesn't mean that these things come easily. There are lots of challenges associated with decentralized identity and verifiable claims. So I listed some of them in this slide, starting with establishing viable ecosystems, all different type of governance issues, commercializations, and making sure these environments and these models can sustain themselves over time, ensuring reliability, recoverability, performance, scalability, and many others. One particular one around user experience, that we actually make the user's life easier, not to make them a system administrator that they need to sit there and manage their own data. So that's the last thing we want to happen. So in a way, we want to make digital identity and data associated with that invisible for the user, and make it a second nature for them to use it as part of transactions. So we still have some time to get there, but one good news is that none of these challenges are showstoppers. We have seen steady progress to make improvement in these areas, and this is a major technology invention. So we can expect it takes a while that we deal with all the issues and streamline the process and make it work smoothly. So, but to give you a sense of future, once decentralized identities goes mainstream, it really magnifies the relationship experience that users can have in participating in digital ecosystems, either in the physical world or the virtual world. So I think that's very important, and that all happens by pushing complexity down into protocol layers more and more. So I have one recommendation, and that is to prepare for these disruptions. I think this is not a kind of simple product installation that can happen, quickly as a simple project. It requires preparation both from business and technology perspective, and all the organizations need to do at this point to see understand what ecosystems are relevant to them, how decentralized identity can play a role, what are the potential verifiable credentials to begin with, what use cases make sense for experimentations, and look at different issues around opening digital neutral digital identity channel, looking at issues, legal issues, and that it may impact this type of project. So and from a technical perspective, look at what tools and specifications are available, and try in your labs to implement some of these things, and try to make your developers familiar with these capabilities, and eventually test some of them, or even deploy this technology in some of production setups. We have actually examples of organizations that now they're deploying this in a limited way in some of their actual production environment, and they are providing some positive feedback. So in any case, just get ready, be prepared to prevent any shock to your system. So with that, I want to thank you all for listening to this presentation. I hope you found it useful. Thank you. Bye.
Who else is excited about the future of Web3? I know I am. Thank you to Homan for an outstanding presentation. Next up is Ivan Liljeqvist, also known as Ivan on Tech, founder and CEO of Moralis Web3, who's going to talk about full stack metaverse development.
Right guys, welcome to this presentation about development, and more specifically we're going to discuss metaverse development, and we're going to speak about full stack metaverse development. In this video, in this presentation, I will explain what full stack really means when we're speaking about the metaverse, what kind of challenges we face when we are building full stack dApps in the metaverse, and what solutions there are on the market to solve them. First and foremost, my name is Ivan. I'm known as Ivan on Tech Online. I'm the CEO and co-founder of Moralis, and we do Web3 infrastructure, Web3 APIs, Web3 SDKs, and all kinds of other tools necessary in order to have a good life as a developer, because at the end of the day, this is what it's all about. It's all about developers having a great life. And that's really what leads to mass adoption. And we need mass adoption. So that's why we go to work every day, to ensure that crypto gets mass adoption by helping developers. First and foremost, why should we care about the metaverse? Why is it important? Well, this is really the next frontier. Just like the smartphone became the platform that captured everyone's attention approximately 15 years ago, the same will happen with the virtual reality and augmented reality soon as well. So the trend is that we are moving more and more towards digital. Our experiences are more digital than ever before. And if you follow the trend and you extrapolate the trend, you're gonna see that it's a good chance that our kids spend most of their time in some kind of virtual environment. And there's a good chance there is going to be either VR or AR. And that's where commerce is gonna happen. That's where meetings are gonna happen. We're gonna meet different people, just like the smartphone is where we meet different people today. So there's a good chance that the metaverse really is the next frontier. And metaverse, nobody can really define it. You ask Mark Zuckerberg, who renamed the whole company into Meta, he cannot even define it. But we can basically say it's some kind of platform where we have all kinds of different applications that has to do more with VR and AR than with flat screens that we have right now. And right now, we are like we're pre-metaverse. We're building all these metaverse experiences, but they're more like games, more than metaverse. But we gotta start somewhere. And we gotta see where is the world heading? Where are all of these different trends taking us? And then when you look at different financial analysts who are predicting, for example, 1 trillion revenue opportunity in the metaverse, or 13 trillion in the metaverse, different financial analysts have different sizes of imagination, but they all speak in trillions. So this means that this is a very important industry. And one of the biggest tech companies, Facebook, renamed into Meta. And there is something here. We know that there is something here. We still cannot really define metaverse ourselves. And nobody can, but we know it's going to be something with VR, with AR. It's going to be something where we are meeting different people, not through screens, but through more immersive experiences. And of course, if the tech is there, if the immersive tech is on the market, it's a no-brainer that we are going to spend even more time online. But as this is happening, we do see troubling developments. The fact that, for example, Meta wants to take nearly 50% of the revenue as a cut. Just like Apple takes 30% of the revenue on the iPhone, the same is going to happen with the metaverse. If we allow the tech giants, the big tech, to own metaverse and to control it. And this is really why Web3 exists. Many people ask me, hey, Ivan, what is Web3? You speak to relatives, you speak to friends, what is Web3? And too many people explain it in the wrong way. They start speaking about, trading, NFTs, staking, yield, all of that stuff. But really, it's about one thing and one thing only. That's digital ownership, digital property rights. That is what is Web3. And that is why it's so important when we are speaking about metaverse, because if it is the case that we are getting more digital, more immersed, then of course you gotta have ownership rights. Because if these universes, digital universes, are very important to us, and our friends and connections and ownership, whatever we have in those worlds is also important to us, it's important to have property rights. And right now online, we don't have property rights. You can be deplatformed from anywhere for whatever reason. You can be really removed from the digital world for whatever reason, and all your assets with it. And this is where Web3 comes in. With currency, number one, that we have cryptocurrencies, but also with all kinds of other digital property rights. Just like Lens protocol is now bringing property rights to social media, just like we do see NFTs bringing it to art and collections and so on and so forth. Anyway, we have to act. You understand that we have to act. It's very important that we come together and we do something and we act. What we just discussed is this, that only Web3 can ensure digital ownership. And a grand journey begins. Why is it so difficult right now? We have this great technology, which is Web3, which gives property rights and ownership rights online, but why is it still so difficult? Why don't we have worldwide adoption? Well, because there are a lot of things to think about. Well, number one, you got to take care of your on-chain logic. So here's where the smart contracts, the transactions, and the money flows actually happen on-chain. Then you got to do the off-chain. And this is, in many cases, the most difficult thing, because you have many different blockchains. If you want to build a metaverse application that supports Ethereum, Polygon, Binance, Solana, you got to parse a lot of data in real time. So really, you're building a big data application, but also it is real time. It's actually very difficult. And then you got to build a UI and UX logic on top of that. So these are the three layers of a full stack metaverse application. And if you look at the different technologies you have for the different layers, for the on-chain logic, you of course have Ethereum, Solana, Elrond, Polygon, and for on-chain, you build smart contracts and you use different programming languages such as, for example, Solidity for Ethereum. You can use Viper for Solidity for Ethereum as well, and other EVM chains, but Solidity is by far the biggest. Then you have Rust on Solana, and then you have all kinds of other different L2s and L1s. So this is the smart contract, the on-chain part, the money flows. This is where you need full decentralization. This is where your ownership is recorded. Then you got to do the off-chain logic. And here normally you would be doing some kind of backend application, whether in Node.js or Java or .NET. And this is in order for you to make your application usable. Because although all of these things happen on-chain, how do you present them on a screen? How do you notify the user? How do you present the user with useful information, with useful UI? For that, you got to do a lot of indexing of the blockchain. And here is where you do see all of these different traditional backend technologies come in that can, for example, be used in order to extract data from on-chain, to put it into databases, to make it useful for users. And this is where most of the time is spent. It's on the backend, because this is extremely difficult, because it's really pushing the envelope when it comes to traditional Web 2 technologies. Why? Well, because we have a very interesting use case where all of the data is real time. So it's very difficult to cache anything because everything is changing all the time. You think you have the data, but no, in 1 second there's new data, and now everything is to be updated. So just from a technical challenge, it's very interesting challenge, and it's very unique challenge, because you have big data, massive amounts of information flowing, especially if you're building cross-chain, and especially if some blockchains are spewing out, tens of thousands of transactions per second. You gotta parse all of that, you gotta make sense of all of that, and to make something useful out of it. This is extremely difficult, and this is really what we're doing. Moralis started in order to make this easier, this whole backend thing easier. And then you have the front end, which basically connects to your backend to get useful information, that has been taken originally from the blockchain but just been indexed, parsed, where you can get real-time notifications and so on and so forth. And on the front end, you have React, Angular, Vue for web, Unity, and Unreal for game and for game engines, and then iOS, Android for mobile. So this is basically full stack for metaverse that you have. Because when we're thinking about this immersive experiences, it's probably going to be built using Unity and Unreal specifically. It's going to be built using game engines. So what is the workflow? Well, the workflow is that, number one, you got to create the smart contracts. That's very important. You use Solidity, Rust, Viper, and then you use tools like Hard Hat, Truffle, Foundry in order to deploy them, to test them, and so on and so forth. Then you got to connect to the backend. So we mentioned some use cases where you got to index a bunch of information, but if you're just starting out to build, let's say, some kind of game, the first thing you have to do is to authenticate the user, because when you connect the wallet to your website, that's not authentication. It can be fully faked. I can create a fake wallet that, you click connect wallet and it will say that I have 1 million tokens of whatever. It's easily spoofed, that address that you have when you just connect wallet. And then you have another thing, which is authentication, where you connect wallet, but then you also sign a message, you create a web session with the backend. And that's the first thing you have to figure out. If you have a dApp that has users, how do you make authenticated sessions with the backend based on the wallet? All right, you gotta figure that out. You gotta figure it out. Then in real time, you gotta know what the user does. Did the user trade? Did they swap something? And you gotta do it in real time. And then you gotta also watch smart contract activity. Did the smart contract do something? Did the smart contract enter some kind of state? So all of this is real-time technologies that you have to build to watch what the user does, what kind of assets the user has, and to watch what the smart contract does, and what kind of assets smart contract gets sent and that the smart contract sends out or mints, and so on and so forth. And then you got to connect this all to the front end. So you got to write SDKs and abstractions to make it all work. So this is the workflow that we need to follow when we are building full stack applications in the metaverse. And why is it so hard? Well, again, start with authentication. There are many chains and wallets that work differently, different standards. It's very security critical. So if you make some kind of mistake here, it's going to be very, very bad. And it's going to be very, very critical mistake, because by definition, it's security, it's user auth. And like we discussed here with all the things, it's enormous data pipelines. You got to build so much to do so little. And also the nodes are dumb. If you're connecting to an RPC node, you're wasting so much time, because an RPC node cannot even tell you what kind of assets a user has. An RPC node cannot even tell you all the metadata of an NFT, because in many cases you got to do several requests to fetch it. So this is a mistake many people make, that they connect straight to the RPC node trying to build their app. It's kind of like connecting straight to the CPU when you're trying to build a website. Why would you do that? You can use HTML. So that is why it's so hard. And what it results in is that you just want a small dApp, but now you need to have 10 engineers to do all of these pipelines. You're stuck fixing bugs, and your competitors grill you because your competitors use tools and solutions. And here is our tools and solutions that we're offering at Moralis. And if you haven't seen us, you can go to moralis.io. You see our website. You see our products, a bunch of different APIs, and also authentication, which I will show you soon. And this is one of the key, most adopted tech stacks right now in Web3. We started last year, but the growth has been insane because we're really focusing in on the biggest pain points. So let me continue discussing this. So first and foremost, we have an auth API, which means that you can connect your wallet, you can connect your user wallets to your backend very easily. And this is what we discussed in the previous slide. How do you connect a wallet and you establish a session? But also, how do you connect the wallet, establish a session, and integrate it with other identity providers such as Auth0? Because if we are to onboard all of the Web2 developers into Web3, we got to be compatible with Web2 standards, such as Auth0, which is a very widely adopted solution, or with AWS Cognito, and so on and so forth. So our Auth API does all of that. It really unites Web2 and Web3 identities and ensures that Web3 identities are very easy to use. Next is our Streams API. So this is all about getting webhooks whenever something happens. Whenever something happens on chain, whenever the user mints, burns, or does anything on chain, we give you real-time notifications. And right now it is via webhooks, and soon we're going to have different other technologies such as Kafka and so on and so forth. But you can go here to our website, moralis.io, and then you can go to products, and then you can read about the Streams API. So Streams API, it is launching this week, so you can get early access here and you can read more about it. But this is one of the key systems that has been powering Moralis for a very long time. And now we are opening it up to the public, because this is one of the most important building blocks in a real-time blockchain application. Next, all the different APIs, whether it is an NFT API, which is the biggest right now in the industry. We really started the first NFT API last year, and then we did see so many problems people had without our NFT API. So we really started to push it like never before. And right now we do have the biggest NFT API where we resolve all the metadata. You can get all the owners, you can get all the assets, everything from our NFT API. We have Solana API for getting tokens and NFTs from Solana. We have EVM API. So if you want to learn more about that, go to our website, go to documentation. And here you can read all about it. So let's say you want NFT API, you go to the reference here, and you can even try here on the live website to do requests, and you have already a demo key, that you can try. So definitely go here and start experimenting. Next are the SDKs. So when it comes to Moralis, we offer SDKs for connecting to your backend. So let's say you have a Node.js application, you can easily connect to all our services via the SDKs. And we also have, for example, Web3 UI Kit, which is enabling you to easily integrate with the front end. So you can just Google Web3 UI Kit and you will find it. All in all, guys, I hope you understand, number one, the importance of why we gotta build ownership online. Metaverse is all about ownership online. All of these different experiences, you gotta have ownership. Also, if you want to learn more, subscribe to our YouTube. We push videos each and every day, and you're gonna learn how to do all of this practically if you subscribe. Join our Discord if you have any questions, and we would love to work together. If you are on our frequency, if you feel that what we're doing is important, you're excited by it, go to talent.moralis.io and apply to our open positions. You can also go to moralis.io/MBS, which stands for Moralis Business School, to understand how our company works, our values, our culture, and stuff like that, which can really make you understand us better and give you an insight into how we are as a company. So guys, on that note, thanks a lot for watching. Thanks a lot for participating, and hope to see you in this wild space of Web3 building. Have a good day, and goodbye, guys. Goodbye.
Huge passion coming from Ivan and a fantastic presentation. Ownership is a core tenet of any Web3 metaverse for sure. For our next presentation, we're switching tracks to talk about what's possible with interchain technology with Harriet Chow, founder of Bianjie AI.
Hello everyone, thanks for the invitation from SmartCon. My name is Harriet. It is my great pleasure to share our work around interchain, NFT, and how those technologies can be used to support global commerce. I'm going to share like a few PowerPoints. Okay. First, please allow me to introduce myself. I'm Harriet from Bianjie. Bianjie is a Shanghai-based startup dedicating to blockchain innovation since 2016. Bianjie is a Cosmos technology builder since 2017. We are the co-contributor to Cosmos and ArisNet project. And we are also currently lead the Cosmos interchain NFT specification design and development. In 2020, we are really glad and fortunate to be able to collaborate with Chainlink and Cosmos to develop Cosmos as well as BSN to develop the interchain Oracle service for BSN. For someone who might not know, BSN is like blockchain service network. It is the largest permissioned blockchain infrastructure globally. And you can Google BSN to learn more of this effort. So for the BSN network, we developed the Chainlink interchain Oracle service for BSN, and we are also the developer for two very important BSN infrastructures, including like BSN, the permissioned version interchain service hub, as well as its first open permissioned blockchain, Wencang chain. And besides the public chain protocol work, we are also developing regulation-friendly open business systems. We are the developer for Cosmos Enterprise Blockchain Framework, ARITA. We also used ARITA to support building systems for digital bank, for the culture and art exchange, etc. And today, I would like to use one use case we supported last year to explain how interchain NFT technology can be used to support global commerce. Last year, some NFTs that successfully transferred from BSN Wencang chain to Ethereum through Ares Hub using interchain technology. This effort was reported by many medias on the web, and I will explain how this was done. This landmark interchain NFT transfer process involved 4 blockchain networks in both the permissioned environment, BSN, as well as public chain domain. So please see from this chart from left to right. In BSN environment, ARITA-based application blockchain Wencang chain, as well as ARITA, as well as the interchain service hub, ARITA hub. So NFTs are transferred out from the permissioned environment through the interchain, the NFT hub, Ares hub, then get into the public chain space. Such a collaboration illustrates how interchain technology can be used to support global commerce that involves different jurisdiction requirements. For example, in the BSN permissioned blockchains in China, it supports, like in the Wencang chain environment, it supports Chinese artworks registration and domestic commerce with required compliance requirements such as KYC, AML, etc. And for global commerce, interchain technology allows those artworks to circulate to public chain-based global markets, such as OpenSea, with trustworthy data. This interchain NFT transfer is achieved leveraging Cosmos IBC protocol for its advanced capability in supporting interoperability among heterogeneous networks. So I'm going to explain the involved technologies step by step. As mentioned, we use the IBC protocol for interchain NFT transfer. So I guess many of you might already heard about IBC of Cosmos. IBC stands for Inter-Blockchain Communication. Actually, besides of IBC, Cosmos also contributed to another innovations to our industry, Tendermint Consensus Engine and Cosmos SDK. For the discussed use case, the involved application blockchain is BSN Wencang chain, which is built using Bianjie's, using the enterprise permission blockchain ARITA. ARITA is using the Cosmos SDK and using the Tendermint Consensus Engine. So let me explain these 3 core technology modules. First, Tendermint. Tendermint is one of the most important modules in Cosmos SDK, which support BFT networks and consensus. Tendermint was open sourced in 2014, which is really early, and it's quite like forward-looking. And so since then, Tendermint has been used by many blockchains including both consortium blockchains for the enterprises as well as public chains. I've actually put some of the numbers. That is a study carried out in 2019. So in that study, it shows there are more than 40% of all POS, proof of stake, blockchains are powered by Tendermint. Tendermint is really the most advanced implementation of the BFT. The advanced features of Tendermint, such as fast finality, allow it to be able to replicate the deterministic state machines onto computers around the world. So this makes Tendermint can support the interchain hub, building the interchain hubs. Cosmos IBC. Cosmos IBC protocol enables the Internet of Blockchains. IBC stands for Inter-Blockchain Communication Protocol, which is a reliable and secure communication protocol that handles reliable transport, authentication, and ordering of data across different heterogeneous blockchains. Analogous to TCP/IP for the Internet, you can see on this chart, IBC is on the transportation layer. Bianjie, we also developed a simplified version of IBC called TIBC, which stands for Terse IBC, which it is a subset of the IBC protocol with some modifications to simplify the interchain connection and expand the application layer capability to support interchain NFT transfer, which enables the digital assets, which has complicated real-world data, can be transferred frictionlessly and trustlessly across blockchains. TIBC with the interchain NFT is the interoperability tag we use to build the multiple hubs and connections to support the transfer of NFT from BSN permissioned blockchains to Ethereum OpenSea. Right now, we already built TIBC bridge for BSN consortium blockchains, as well as to Ethereum and to BSC. The third core contribution from Cosmos project to our industry is Cosmos SDK. Cosmos SDK is very modular and extensible and very suitable for building the sovereignty blockchains. Today, there are over 6 million in assets are managed by public blockchains built with Cosmos SDK, and Cosmos SDK is the most popular blockchain framework in the world. So, with Cosmos SDK, you can just simply plug the existing modules, such as the Tendermint module, the IBC, to add those features to your blockchain. And you can also build new modules and share them downstream to enrich and contribute to the blockchain open source ecosystem. And Bianjie, we are the open source developers, and we are currently supporting the NFT module in the Cosmos SDK. And we are also dedicating to develop the enterprise supporting modules such as the ID management, etc., for the Cosmos ecosystem. So as discussed, we're contributing the enterprise modules for Cosmos SDK, and so build the Arita enterprise blockchain. Arita is used by many blockchain implementations, and for example, the Wenchang chain, as well as the interchain hub in BSN environment. And also, we use the Arita to build for many of our enterprise customers, including the Asia Digital Bank, which is an innovative global digital bank. The open architecture of Cosmos supports independent interchain hubs to collaborate. Right now in Cosmos ecosystem, besides Cosmos Hub, we also supported building the second hub, which is called IrisNet, and also known as Iris Hub. The focus of Iris Hub is NFT, as well as connections to enterprise blockchains. And as illustrated in this chart, right now, IrisNet is supporting the NFT market, such as Uptick. The IrisNet's connection with BSN and Ethereum are live now since last year, and support the NFT transfer from the BSN environment to Ethereum. and the ArisNet connections to the Asia Digital Bank open permission blockchains are going to be launched soon. We just explained how TIBC, Interchain NFT, and ArisNet to support the reliable connections from enterprise consortium blockchains to Ethereum OpenSea. With the Interchain technology, the Chinese traditional fine arts, including the paintings and porcelains, can be registered in the Wencang chain, which supports the China law compliance requirement. And then the NFTs bearing the real artworks digitized rights can be transferred across the consortium chain, including the Interchain Service Hub to the public chain space to support the global commerce. The Interchain technology not only allows users from different countries to satisfy their core business needs with blockchain that meets their country's compliance requirements, but also supports the trustworthy communication of information within the cross-country business. We are also using the same tech stack and infrastructure to support Hainan International Culture and Artwork Exchange. We are proud to build the industry-leading interchain technology for the mass business adoption. We believe this sets a new paradigm for NFTs and establish how interchain technology can be used to support the global commerce for different jurisdiction requirements. So this will incubate more interchain NFT implementations in the realms of cultural exchange and trustworthy global trades. Cultural communication and the commerce exchange promote global collaborations for common development. Blockchain is said to be the value network. We are very proud to be a builder for the Internet of Values since 2016, and we look forward to continuously working with blockchain open source community to leverage NFT and interchain technology to support building a better world. Thanks very much.
Awesome presentation by Harriet on interchain technology and interoperability, and excited to see what cool new use cases come out of it. Our next speaker is Anatoly Yakovenko, co-founder of Solana.
Hello, Anatoly. Welcome to SmartCon. I'm so excited to have you here. I believe, for the audience, Anatoly, you need no introduction. As the founder of Solana, you've been a leader in the space, really helping usher in this future world of Web3 and decentralization. So I guess to even start with, Anatoly, let's start with the basics. When we talk about trust minimization and applications that are being built with principles in that mind, what do you think that means?
Well, I think crypto first of all, thank you for having me. And I think crypto's ethos is around empowering the user. It's really giving the user control. And it almost starts with the very basic idea of self-custody. It's having the user have the keys that reflect ownership of a digital asset. So with Web3, I think as the concept of what a digital asset evolves, you get into much more complicated things, from NFTs, from a position in a pool, in a lending pool that's Oracle driven by a Chainlink feed, or positioned in AMM. These are all digital assets that are under the user's control, and how they function and operate, I think, is really important to make sure that users have the transparency and the control at all times during that process.
I love how you talk about users and talking about, how Web3 offers us, as users to change how, with the social and economic relationships that we have, right? I'm curious, what do you think is Web3's impact on how we interact with each other?
So I think it's still really early. To me, it almost feels like 1994 when there were about 10 million people on bulletin boards and stuff, and you're trying to predict Facebook, that 20 years later, there's going to be a social graph that's worth $500 billion. And it's a really tough thing to imagine, but the kind of example that I always like to bring up is that, you've seen things like the Constitution DAO. That was, 40,000 people, maybe at most, that came together to take action. Imagine if it was 40 million. Could 40 million people all come together and make substantive changes in the world? I honestly believe that once we have the self-custodied users onboarded to these networks, 40 million people will come together and buy every coal plant in the world and shut them down. People will actually be able to take real direct action. And I think that's a really, really powerful thing.
No, absolutely. Yeah. Instead of just buying the Constitution, right? You can actually make a new Constitution and implement it and be a little country.
Right, exactly.
Yeah, really cool. And earlier this year, Chainlink price feeds launched on Solana. I remember was a major milestone, as it was Chainlink's very first non-EVM chain integration. Can you speak to a bit to the role that oracles like Chainlink play in enabling this, trust minimized products and services we're talking about?
Oracles are the core part of what makes all the sophisticated parts of DeFi work. You can't have a lending protocol without an oracle. You can't run derivatives or any other kind of interesting pieces without an oracle. So I think they're just really critically important. And I think as the crypto matures and we get more and more users on these networks, we'll start seeing other things being implemented by Oracle. I can, eventually I'll be able to take an insurance against my flight to my favorite vacation spot that it's never going to rain, right? And that has to be driven by an oracle, because ultimately the oracles are what provides the eyes to the network, they're actually the things that observe any outside events.
Yeah, no, very true. And I'm sure everyone wondering, what is your favorite vacation spot if you are open to sharing?
I am a huge fan of California. So over the last, 4 or 5 years, I've just been traveling up and down the coast. And I would say Solana Beach is still one of the best spots in the world.
Absolutely. Namesake of Solana, right?
Yeah.
And what are some of the most exciting use cases and products that could be built on the Solana ecosystem that you think would be able to use these Chainlink battle-tested oracles?
Well, what I love about Solana is its speed and throughput. And I think that's a really differentiator from, I think, all the other networks combined. You look at go to websites like RealTPS, Solana literally does more transactions than all the other networks put together. And the kinds of DeFi products that people can build, I think, are just much more interesting. You don't need to use an AMM. You can actually build a central limit order book. And folks are starting to take those concepts and apply them to the next generation of DeFi protocols. So now in the last hackathon, Lulu Finance built a whole lending protocol, something similar to Aave, but it runs on a central limit order book plus an Oracle feed. So it's really important that we see products that utilize a high performance, low latency feed alongside these high performance markets. So I'm really, really excited about the next few years of folks building these out and making it possible to, I think, for DeFi to compete with centralized services.
No, absolutely. Yeah, you need speed, right? And you need accuracy, and you need reliability. And together, Chainlink and Solana were able to help deliver that to the dApps they're actually building on it. And then when we talk about global impact, the scalability of decentralized infrastructure stands out as one of the largest challenges facing, the Web3 industry. I'm really curious, how does Solana take on this issue of scalability and high throughput?
This is kind of our ethos is that a lot of the work is already done by companies like NVIDIA, by Intel, that every 2 years they double the number of cores in these systems and make it cheaper and cheaper to push more transactions through these networks. And that doesn't mean that our job is easy. It still takes a lot of work to write the software to take advantage of it. But at least it's something that will clearly work. So as you see the network go through hardware upgrades and through software upgrades, it continuously increases its bandwidth, like the amount of transactions it can handle, and reduces in latency. And that to me is really that evolution and constant iteration, I think is the most important part. And in a lot of ways, it's very similar to Linux, like the open source kernel that everybody loves. Every year hardware changes, every year Linux takes advantage of it. And we're excited to be kind of part of that journey.
Yeah. Well, in this journey of constant evolution and innovation, I mean, I was really excited to hear about the new Solana mobile software stack and the Saga phone. I'd love to hear, more about, why you felt this was a necessary advancement for the broader crypto ecosystem.
So crypto needs to be treated as a first-class citizen in these mobile platforms. And because of my background and most of my team are former Qualcomm folks, we felt like we can do it. So I think what this really enables for users, though, is that they know that wallets and the applications and apps that they're using can never steal their seed phrase. You'll never get an update from a wallet provider that accidentally logs your seed phrase externally to the device, because the seed phrase is hidden in a secure element that is not even on the same chip as the operating system is running. So you have this almost hardware grade level of protection. And that to me means that wallets can now actually iterate much, much faster. They can build very rich applications to do much more than they do now. And that's the exciting part, is that like by having the operating system and the hardware work doing the right thing and actually storing and providing security, all the applications can literally just kind of have a ball and build awesome features and be competitive with their Web2 counterparts. And obviously, I think one of the key elements to the Solana mobile stack is the dApp store. You see that the Web2 business models are just not really making sense these days. Companies like Magic Eden, they can't take a user-built asset, a decentralized asset, and charge 30% more on their mobile version. That just doesn't make any sense, right? So you need application environments that treat digital assets the same way that they treat physical goods. So this is, I think, a big fundamental change to the business model of how dApp Store runs. So I'm pretty excited about the aspect of that as well.
I mean, no, that is huge. And of anybody, right? You have Qualcomm engineers who are the best at for creating the mobile phones out there, chips that are in all of our cell phones that people don't even recognize. So you guys are the best position to do and take on something monumental like that. And as we think about that, what else do you think is currently missing from the Web3 space that we need to propel it to the next level?
I think all the pieces are there. I think honestly that technology-wise, the last 4 years have been just tremendous improvements, not just in Solana, but you see things outside of Solana advance at a really rapid pace as well. And like the biggest constraint now is, awesome entrepreneurs that want to take that plunge and build amazing applications and scale them to users. That's been, I think, the challenge always, but right now, I think is the best time to do that, because we are in this so-called bear market, but as I like to call it, a build market. This is the best time to start a company and start iterating and really grinding on figuring out product market fit, because when you do so, and then the macro environment changes, you really, really can grow really quickly. And this is, I think, the biggest opportunity, I think, for this generation of entrepreneurs.
Absolutely. I mean, you are quite the inspiration for a lot of entrepreneurs as well. I mean, any words of wisdom for people who are thinking of taking this opportunity to build?
I would suggest that you go check out one of the Solana hackathons. That's like the easiest way to get started. But even if you don't, I think focus on an idea and something that you love and you think will bring value to the world, and then just build and iterate, and eventually you'll get there.
Yeah. And then final question, I mean, where do you see the Web3 ecosystem in 5 years? And then next after that, where Solana is important to getting us?
I think in the next 5 years, we will probably see some breakout thing that causes us to go from, I think, the 10 million monthly active users that are actually signing transactions across all the networks combined to 100, 200 million. And when that happens, I think we'll see those breakout applications, the Facebooks that we really can't even predict. What is actually going to be driving those? So I'm really excited about that. I think given Solana's performance and like hardware trajectory, I'm hoping it's 99% of transactions in the world are running on Solana at that point.
That's good. Sounds like a vicious but doable goal. Well, thank you again, Anatoly. Thanks for coming and sharing your wisdom with the audience here at SmartCon, and excited for future collaborations with you and Chainlink.
Thank you. Take care.
Really cool presentation by Anatoly. It's awesome to see the variety of different topics that these speakers are interested in. Next up is Justin Sun, founder of TRON DAO, who will present on the TRON ecosystem.
Hi everyone, I'm Justin Sun, founder of TRON and the ambassador of Grenada to the WTO. I'm pleased to be speaking at the SmartCon 2020, held by Chainlink. At heart, I'm a tech entrepreneur with a passion for accelerating the decentralization of the internet through blockchain technology and the decentralized applications. I discovered my calling and passion for the industry during my time at UPenn, and I started working in blockchain space. This eventually led to the founding of TRON in 2017. In 2018, TRON joined forces with BitTorrent, the leader in peer-to-peer technology, with the aim to build a free global file distributed system with distributed storage technology that allows easy and cost-effective sharing of digital content. With a highly scalable, fast, and affordable infrastructure, TRON has grown to become one of the largest and the most popular blockchain ecosystem in the world, and has established itself as a high agile protocol. TRON is leading the charge in the shifting global tides towards Web3 revolution. TRON has one of the most vibrant communities across the globe and is dedicated to making blockchain technology accessible to everyone. In December 2021, TRON announced the dissolution of its foundation and the official transition into a DAO. Since then, TRON DAO team has continued to deliver milestones after milestone, accelerating the growth and the expansion of the ecosystem. which has been truly rewarding and exciting to witness. The TRON Grand Hackathon is an excellent example of a recent initiative from the TRON team to fast-track a future widely spread adoption of decentralized platforms and applications. With the increasing using of decentralized peer-to-peer and secure networks, blockchain is become the backbone of Web3, a decentralized web. The TRON Grand Hackathon creates opportunities for unheard talents to making their marks and accelerate the development of Web3 while promoting the growth of TRON ecosystem. Season 1 of the TRON Grand Hackathon has over 200 participants across 4 tracks: Web3, DeFi, GameFi, and NFT, competing for a total $500K US prize pool. Season 2 recently concluded as a big success, with over 1,800 participants competing for $1 million in prize across 4 tracks. Season 3 of the hackathon just kicked off on September 20th with a further increased 1.2 million in total prize. It now features 2 additional tracks focused on Euro University students, the TRON Academy track, and the Ethereum projects looking to exploring all that TRON has to offer. The ecosystem track, Ethereum edition. Even during uncertain times, TRON has continued to maintain its organic growth. Earlier this year, TRON overtook Bianjie chain as the second largest chain in terms of TVL, according to DeFi Llama. TRON is also the second largest blockchain of stablecoin, with USDT and USDC. Now, the stablecoin market cap on TRON protocol has reached over $40 billion US. During this bear market, TRON has stayed focused on launching various initiatives and the overall good for its community and larger crypto space, launching a variety of grants and programs, such as TRON 101 program, the 1 billion ecosystem development fund, and a 10 million relief fund to encourage Terra and other blockchain developers to migrate their projects to the TRON and the BTTC ecosystem. The launch of USDD, the most famous over-collateralized decentralized stablecoin on the market, was another significant milestone for the ecosystem, and now available on TRON, BNB chain, and Ethereum. USDD price stability is maintained through a basket of monetary policy tools adopted by the TRON Reserve, TDR, based on the market conditions. The price of USDD is pegged to US dollar with over-collateralization of TRX, BTC, USDT, USDC, and TUSD. An analogy is the link exchange rate system, LERS, established to maintain the Hong Kong dollar's link to US dollar. In the first stage of the development, USDD is minted only by the whitelisted institution of TRON Reserve through burning TRX. And now you can also mint USDD through PSM, Peg Stability Module, from TDR and USDD in a decentralized way. Basically means you can deposit USDT, USDC, and TUSD into PSM to mint USDD. So the minting of USDD is also become decentralized. The circulation and the use of USDT are free from intervention of any centralized parties. The details of the TDR reserve assets are published in real time on TRON Reserve website. As of now, the total market value of all the reserve is well over 2.2 billion US dollars, about 3 times the value of 700 million USDT in circulation. In addition, the minimum collateralization rate is set to at 130% to ensure a strong buffer for stability. The shift towards greener, faster, and more efficient solution has been a major trend this year, and many cryptocurrencies are adopting proof of stake consensus rather than energy-dependent proof of work. TRON is a leader in creating an affordable and environmental friendly ecosystem, primarily due to the underlying depots mechanism and is more energy efficient than regular proof of work and proof of stake protocol. Recently, the Crypto Carbon Rating Institute, a neutral organization with a strong academic background, revealed in their research that TRON blockchain consumes 99.9% less power than Bitcoin and the Ethereum blockchain, as is about to equivalent to 15 US households per year. TRON will continue be conscious of its ecological impact and work towards carbon neutral and the carbon negative future of the blockchain. TRON also emphasizes on its stablecoin strategy. TRON collaborated with Tether USDT in 2019. Later, we successfully grew the stablecoin adoption of USDT on TRON to over 40 billion US dollar market cap, and at the same time with over 10 billion US dollar worth of transaction every day. Today, the holder of USDT on TRON blockchain has surpassed 15 million users. Also, of course, the overall TRON ecosystem grew dramatically. The holder number now is 110 million users. In 2020 and 2021, TRON successfully partnered with Circle and Trust Token to launch USDC and TUSD on the TRON blockchain. Now, these two stablecoins has also increased dramatically on TRON network, with both together about 3 billion US dollars. TRON is always dedicated itself to become the next settlement layers for stablecoin and the crypto assets. We'll continue to fund it and help developers to build DeFi and NFT applications on TRON network. TRON continues to focus on NFT and GameFi industry. We collaborate with Aave NFT, which is a very popular top 200 projects on CMC, on develop Aave NFT trading platform to launch various prestigious NFT projects, including Icon and various Olympic champions on TRON network. And also, at the same time, we invest in Win NFT Horse and Win NFT Hero, two big play-to-earn GameFi products, along with Binance NFT. The users of Win NFT Horse has surpassed total 500K, and the daily active users is around 40K. And we recently just launched Win NFT Hero with Binance platform. The first 10,000 NFT on the platform sold in few seconds. If you are GameFi and NFT developers, feel free to reach out to us and our hackathon. We are happy to sponsor and support you build both on TRON and Ethereum blockchain. In speak of DeFi development, TRON is also very big. We are the #2 blockchain in terms of DeFi TVL. TRON blockchain just land, and SunSwap, Sun.io, has become the most popular DeFi application in the world in terms of lending trading. We also collaborate with Chainlink to develop Oracle on TRON network. And also, of course, we collaborate with Chainlink on USDD, BTT, TRX, price feed, and supporting DeFi application on Aave compound to support TUSD and other TRON ecosystem token price feed. To all the builders out there, remember that crypto is very new and vibrant space with tons of ideas being created daily. Make sure to build something you are passionate about. Don't be afraid of making mistakes. And the crypto continues its trend and goes mainstream. We can expect it a rise in demand for fast, cheap, and scalable blockchain protocols. And the TRON is positioned to rise into this spot. By staying true to our mission and continually to be agile, I believe that TRON will grow to be the blockchain protocol of the future, the global settlement layer. Thank you, everybody.
Big thanks to Justin for his presentation on TRON and its ecosystem. It's hard to believe we're at our final presentation. Get ready to hear from Tim Beiko, Protocol Support at Ethereum Foundation.
Hi everyone, my name is Tim Beiko, and today I'm going to talk about how Ethereum works in a post-merge world. So let me share my slides here. Okay, so as all of you may know, Ethereum just went through a pretty big transition to move from proof of work to proof of stake. So today I wanted to take some time to kind of share the context behind that transition, walk you through exactly what happened, and kind of give a picture of what Ethereum looks like today and how the network works. And so to take a little step back and kind of start from the beginning here, Ethereum always had this desire to move to proof of stake. It was part of the initial roadmap even before the actual chain launched. And as soon as basically Ethereum was live, work shifted to try and design a proof of stake algorithm that Ethereum could switch to. And around 2018, we had something which we almost went to production with, but ended up ditching for a few reasons. And at a high level, the main reason to move away from this was just that it was very closely coupled with the existing proof of work chain and kind of brought in a bunch of technical constraints from that chain that made the system quite worse. So first, the proof of stake algorithm was designed as a special contract, like a kind of enshrined smart contract on the network, which had different operation constraints than normal smart contracts. So it added all this extra logic in sort of a semi-detached way from the network. And the initial design also had like quite a high minimum stake required to be a validator. It was 1,500 ETH. And also, At the same time as research on this was happening, people were already thinking about how we go and scale Ethereum. And we're coming up with similar designs and hitting similar constraints for things like sharding. So around 2018, there was this realization that, well, maybe this design is not great. And then the kind of thought was, what if we just designed a proof of stake and sharding Ethereum from scratch? What would that look like if we had none of the constraints of the current proof of work chain? And so this is where the Ethereum 2.0 roadmap came about. So the idea was that you would redo everything from scratch and move all of Ethereum to this new system, which would be re-architected from the ground up and kind of perform much better than the current proof of work chain. And so when people talk about the Ethereum 2.0 and the sort of phase 0, phase 1, phase 2, this was the idea. Phase 0, the idea was you would launch the proof of stake chain separately from the system and first get that up and running so that you can make sure everything works there. Then instead of directly scaling computation on the network, we would launch shards, which would execute in parallel and anchor back to the beacon chain, but they would only store data rather than execute transactions. And then finally, once we were confident that the system was stable, we would turn on computation in those shards and get all the applications to migrate to the new Ethereum. And this is kind of the roadmap that was talked a lot about in 2018, 2019, and 2020. And as you can see, we actually did do part of it. So we did launch the beacon chain separately. But there were some problems with this. It still wasn't quite perfect. The biggest open question was, if we do this phase 0, we launch the beacon chain, we do phase 1, we add these data shards. It was never quite clear how we would turn on computation in those shards and what that would look like. This also implied that we would need users to migrate from the current chain to another one, and that all the applications would have to be redeployed. People would have to move their funds over, so that would be quite complex. And then the other thing it would require is it would require new software to execute all the transactions in those computation shards. And we know just from history how hard it is to write these Ethereum clients. So we have some on proof of work, we have some for the beacon chain, and it's quite a lot of work to write and maintain these. So while these problems started showing up on the roadmap, there was another thing that happened in the space, which was kind of the appearance of rollups. And the idea there with rollups is that you can scale computation on Ethereum using layer 2s rather than the protocol itself. And so with this kind of emerging, you can see there were a couple refinements to the original Ethereum 2.0 roadmap that led us to what was the specification we ended up using for the merge. So early on, when there was this realization that it would take time to launch the beacon chain, deploy data shards, turn on computations in those shards, Vitalik put a proposal to say, what if we simply made the proof of work chain the first shard of Ethereum 2.0? So this would get us kind of Ethereum moved to proof of stake. It would allow us to test the system, and we wouldn't have to wait for all of these computation shards to be migrated. And it might also mean that there's actually no migration for users because the proof of work chain just becomes sort of shard 0 of the new system. And then there's a second kind of refinement on this idea almost a year later, which was saying, what if we actually ditch this part around executable shards in the roadmap and simply focused on rollups for scaling? And the interesting thing there is that rollups generate a lot of data. Either they post transaction data back on chain or proofs of it and state this with ZK rollups. So the first 2 bits of the roadmap, having the beacon chain and having the data shards, is still quite useful for rollups because it gives them somewhere that they can post data back to. But the most complicated bit around turning on this sharded execution, that's basically how rollups work. So this second kind of rollup-centric roadmap insight was saying, well, let's just ditch the most complicated part of our protocol changes, simply launch the beacon chain, have the data shards, and have rollups kind of store their data on those data shards, and we'll have scaling for Ethereum. And then the third refinement that came to this idea was saying, well, what if we keep doing all this, but instead of having the proof of work chain become a shard of the Ethereum 2.0 design, what if we simply change what the current proof of work chain listens to come to consensus? So to change from proof of work to proof of stake. And the interesting thing there is all of the software that ran the proof of work chain already had this concept that it could change consensus algorithms. So basically on Ethereum mainnet, it would run proof of work, but on testnets, for example, it would run proof of authority, and same on private network. So if we could simply kind of reuse all that software and get it to swap its consensus algorithm to something else, and then we wouldn't have to write any new kind of software to execute the proof of work computation. We could just keep things like Geth, Aragon, Nethermind, Besu, have them swap over their consensus algorithm and move to proof of stake that way. And this is more or less the final design we've gone with. And it's worth taking a second to kind of show the contrast between what this initial Ethereum 2.0 roadmap was like and what the sort of roll-up-centric approach we've taken looks like. And without even going into all of the details, just like, glancing at those diagrams, you can see that it pretty much ends up being the same thing, right? Like we get to a very similar end state. On the left side, we see there that the original plan was actually to keep proof of work around for a while, and then have that tethered to the proof of stake chain, which is something we ditched. We moved to a world where we completely just use proof of stake, and that's what you can see kind of on the right side. And then you can see that you can see that on the left side, we have all of these shards that provide data, and then the VMs that link back to them and that provide execution results. And if you look at the right side of the diagram, you basically see that a very similar thing where you have all of these blobs, which are basically the shard chains that provide data. And you have all of these L2s, which are now running the EVM. So instead of having kind of one version or versions of the EVM that are dictated by the protocol, you can have all these different implementations that are done by many teams. And they're not only EVMs, there's obviously Optimism, Arbitrum run EVM rollups, but you can see ZK Sync and Starkware that have different approaches as well. So we end up to a state where we have this kind of parallelized computation that's happening that allows us to scale Ethereum's throughput, that's using the data layer on L1, and we have proof of stake securing that. So this was kind of a much simpler design that ended up getting us to roughly the same spot. And if we zoom in a little bit into the merge, right, this transition from proof of work to proof of stake, what happened there? So first, like I was saying, the idea is to go from proof of work to proof of stake as the consensus algorithm for the network. And this means that, after this transition, what was currently known as ETH1 or the proof of work state chain becomes the execution layer for all of Ethereum. So where the transactions run and all of that. And then the beacon chain, or what was known kind of as the ETH2 part of the system, becomes the consensus layer. And as we said already, the execution layer clients already had this concept where they can switch they can use different consensus algorithms. So it was reusing kind of some logic that already existed. And obviously there was a ton of custom stuff that had to be developed for the merge, but generally like this concept was something that clients were already used to dealing with. And the way that we would trigger the transition is saying, once there's a specific amount of difficulty that's reached on the proof of work chain, the clients stop listening to proof of work as the way to determine the head of the network, and they instead shift to proof of stake. And then in a post-merge setting, what this looks like is that the consensus layer client, so the beacon chain, is running the proof of stake algorithm. It gets the consensus on what the head of the chain is. It's what produces and gossips the blocks, and obviously handles syncing to the right fork on the proof of stake side. And then the execution layer still executes all of the transactions in the EVM, make sure that they're correct and they follow the protocol rules. It still manages all of the state and basically the database and sync associated with that, and gossips transaction on its own peer-to-peer network as well. And if you zoom in even more in like the actual transition process, what happened was this. First, we had an upgrade on the beacon chain to tell it to listen for this terminal total difficulty value that we set, which is the highest amount of difficulty we want to see on the proof of work chain. So once we set this value and deployed the software, this was during the Bellatrix hard fork, the beacon chain and the execution layer are listening, kind of pinging every block, asking, have we exceeded this TTD value? When we see a block who first exceeds TTD, we consider this to be a candidate final proof of work block. And this is kind of the last block that's produced in that chain by proof of work. And producing the next block is then the role of the validator who's assigned in the next slot on the beacon chain. And because reorgs can happen and there can be multiple competing terminal blocks, what we want to see is once this first proof of stake block has been produced, we want to see this finalized so that we know we can't reorg past the transition. And once we had that, this is when we knew that the transition was complete. So I have a graph here by Danny Ryan who kind of shows this more visually. If you go all the way to the left here, you see we have our proof of work and beacon chains both running in parallel. On the top, you have this proof of work block, which has some proof of work, but then within it, there's all of the transactional contents of the block and the data that's required to validate those transactions, like the hash of the block, the base fee, and whatnot. And then right below that, you have a beacon chain block that has all of this data related to the proof of stake chain. You can think of it as like consensus metadata. So, the attestations, all the new deposits, all the exits, the RANDAO and whatnot, but it doesn't have any actual end user transactions being executed in it. And so if you move over one block, you could imagine this second proof of work block would be the one where we exceed TTD. So we consider that the terminal proof of work block. While that's happening, the beacon chain is still operating as it previously did. But then once that proof of work block is hit, that second proof of work block, we see that the third beacon chain block now contains the transactional payload of the previous proof of work chain. And this is basically the merge happening. It's going from this last proof of work block, which has all of the transactions in that, to basically the beacon chain still coming to consensus on proof of stake, but then including what we now call an execution payload, which is the list of all these transactions, as well as all the relevant data to execute them on the network. And then if you move over to the last block on the right, you can see that this block basically has no linking back to proof of work, right? It's a pure kind of proof of stake block, which has all of the proof of stake consensus information as well, and this execution payload again. And this is what we wanted to see finalized. It's just the first block on the proof of stake side, so that we know we can't reorg back to proof of work world. And if you zoom in even more on one of these blocks, like I was saying, the content that used to contain all of like the transaction related data of an ETH1 block now becomes an execution payload, which is part of a beacon chain block. And the goal there was to make the transition as seamless as possible, so that a transaction running in the last proof of work block or the last proof of stake block would execute the same way, that smart contracts and users won't have anything to do. That said, there are like a couple changes that are worth noting. So the first is that the block times on proof of work were averaged to about 13 seconds, but really high variance. Whereas in proof of stake, they all happen every 12 seconds unless the validator is offline. And this currently happens less than 1% of the time. The second thing is that there were several fields in the block that we set to 0 after the transition because they no longer apply. So anything related to proof of work or uncle blocks are basically the things we zeroed out, but with one exception. So difficulty is a value that was accessible in the EVM, and it's kind of a biasable pseudo-random value that is used on-chain for pseudo-randomness. If we move that to 0, then it would go from providing poor randomness to providing no randomness at all. So instead, what we do is we rewired this opcode to return the random reveal from the previous slot in the EVM, which is another source of randomness that can now be used by contracts. So this is really the only change in terms of like contract execution on chain, and it's kind of neat because the size of those values is different. So if you look at the size of the return value of this opcode, you can know whether your contract is executing pre or post merge. And if you look at what an Ethereum node looks like on the network, this is roughly the idea, where an Ethereum client now requires you to run both a consensus layer client and an execution layer client. Without these, if you don't have the consensus layer client, you can't tell what the state of the chain is. And if you don't have the execution layer client, you can't actually execute the blocks on chain. So you need to combine both of them. But because we wanted things to also be seamless for the users of these clients, all of the nodes still maintain their APIs as previously. So if you were using the Beacon APIs or JSON RPC or WebSockets on the execution layer, none of that changes. You still kind of get the same experience. And similarly, both kind of clients as part of the node, so the consensus layer and the execution layer, maintain their set of peers. So the gossip networks remain independent, and the only thing that changes there is that blocks go from being gossiped on the execution level to the consensus level. And then in order for both the consensus and execution layer to communicate, we've introduced an API between them, which is called the Engine API. And this is just an authenticated API where the consensus layer can send information to the execution layer, telling it, what's the latest valid ahead, what's like the state of the network, and it can also request information from it. So for example, it'll send it a block and ask it to validate the block, or similarly, if it's a validator and it has to propose a block, it will query its execution engine and ask it to return a block that it can propose on the network. And so that's pretty much it for how the network works. We work quite hard to have minimal changes to the architecture of clients, to the contents of blocks, to the interface with nodes, and yeah, that's really the main thing we wanted to get, is just having this be a really smooth transition for users of Ethereum. And now that the merge has actually happened, there's a few nice charts I wanted to highlight that I've seen since then. The first one is this. This is from Coinmetrics, and I actually couldn't believe this chart when I first saw it. It shows what the average block time is pre and post merge. So this is taken in like the 12-hour gap where the merge happened. Merge was at about 6:30 UTC, which you can see clearly on the graph. And before the merge, like I was saying, we had this target of 13-second block times, but we had very high variance in it. And I think I personally underestimated the amount of variance that we had. So, if you look at this left part of the graph, all of the red dots are short blocks that happen in less than 12 seconds. But this entire upper part of blocks that take more than 12 seconds is quite surprising. And even if you look after the merge, you can see there's this red line which shows that like most blocks come every 12 seconds, and there's a couple kind of blue dots which show that this validator was offline, so the next block didn't come in 12 seconds, but it came in 24. And so far, there hasn't been like two validators offline in a row, so you haven't seen like a 36-second block on proof of stake Ethereum. And I think it just shows like how much more predictable block times have become under proof of stake. So you kind of know that you can expect something basically every 12 seconds, and if not, might be every 24 seconds. Whereas before, it's kind of wild to see we had blocks that would take between 60 and 80 seconds from time to time, and that those happen, multiple times between this in a 6-hour span. And then related, there's a couple other neat things to notice. Well, the first one on the left here is a chart from Etherscan looking at the daily gas usage. And it shows that, if we went from 13-second to 12-second blocks, obviously there's going to be an increase in capacity on the network. And we can see that quite clearly in this chart. So you can see towards the end, the last couple of days or when the merge happened, and you see the gas used daily has gone up. And one thing that's nice is we've managed to increase the capacity a little bit, and we've also managed to get better pricing on the network. So if you look at this, the right-hand side, the quoted tweet from Martin is basically the same thing as this chart that I showed before, just in a different view. But Vitalik's reply there is saying that the amount of full blocks we've seen has gone from 20% to 10%. And this is quite important because the mechanism we use to price gas on the network, EIP 1559, you can think of as basically surge pricing for Ethereum that goes both ways. So when many people want to use Ethereum, the price goes up. When no one wants to use Ethereum, the price goes down. And the way we're able to calibrate this is by trying to keep blocks 50% full all of the time. So if blocks are 50% full, we assume that the demand is constant, so we don't change the price. And if they're more than that, we start raising the price. And if they're less than that, we start lowering it. But this means that if many blocks are more than 100% full, right? Like there's more than twice as much demand as the current base fee, then our mechanism kind of stops working, right? It stops tracking the excess demand because it gets saturated. And it can take many blocks to kind of recover from that. And one of the reasons this can happen is not necessarily that there's more demand, but it's simply that there's more time between transactions, right? You can think that if blocks are supposed to come every 13 seconds and one of them comes every 26 seconds, which, as you can see on this chart, is quite common, it'll look to the network as though there's twice as much demand, but in practice, per unit of time, the demand was constant. And so because we have these much more constant block times now, we see that we actually have less blocks that are 100% full. So we went from about 20% to 10%. And that's great because it kind of shows that our current pricing mechanism actually works better in a post-merge world, and it gets kind of distorted less often by surges in demand. So I wanted to share these couple charts because even though it hasn't been super long since the merge happened, we're already seeing some interesting effects on the network, and it's clearly shown that things are generally more stable. So that's all I had. Thank you so much for having me, and I wish you a great conference. Cheers.
Thank you, Tim, for an amazing presentation. It's hard to believe we're closing out another SmartCon. Thank you for joining us for the virtual SmartCon 2022 experience. We hope you enjoyed the content, and rest assured that all presentations, keynotes, panels, and firesides from SmartCon will be released on the official Chainlink YouTube over the next few weeks. SmartCon 2022 wouldn't be possible without the amazing speakers, sponsors, team members, and especially you that are attending this event both virtually and in person. Thank you for making SmartCon 2022 an amazing experience. We hope to see you again next year. Thank you so much. Have a great rest of your day.